Okay, let's try another problem. Next one in our package. And you can see water at 10 degrees Celsius flows at 900 liters per minute from the reservoir. Get the pressure at point B, considering energy loss due to friction but neglecting other losses. And of course that would be minor losses. So the minor losses in this case are zero, but the friction are not. You can see that already I've gotten some of the homework out of the way. Housekeeping sort of stuff by getting the properties of water and the properties of the pipe. Our Appendix A, we can look up, get our properties of water at 10 Celsius, 9810, 1000, 1 times 10 to the minus 3 for dynamic viscosity, 1.3 times 10 to the minus 6 for kinematic, as recorded there. That's Appendix A, and then Appendix H has our information about Type K copper. So we want to go down to 4-inch Type K. So there's 4-inch right there. We read across. We don't need the outsider wall thickness. The 97.97 millimeters, which I think I rounded off to 98 on my sheet. And then the flow area is good as well, 7.538 times 10 to the minus 3. Also, one other item that I did not write down in my housekeeping is my epsilon value. And you can see for copper that it is 1.5 times 10 to the minus 6 meters, the second one down. So epsilon is 1.5 times 10 to the minus 6 meters. And that is from our, well, we've got it in a few places in our package book. So, I think we're about ready to go. The other thing I did get was, I noticed we had the flow rate, and we've only got one size pipe, so getting the velocity is nice to get that out of the way. So I did the calculation there as well. So setting up the equation, looking at point B is what we're interested in, and note, of course, the pressure B is, point B is not open to atmosphere, it's in the pipe, and so we'll consider that. We're looking at point B. We want to consider another point. One that, of course, always jumps out at me is the top of the reservoir, because we're open to atmosphere, and our velocity is pretty much zero. Looking around, I can't see anything else that jumps out at me. No other reservoirs or anything open to atmosphere. Points with the same diameter. Yes, that pipe is all one diameter, but it doesn't look like any other point has a whole lot of information there. And similarly, points at the same height. There's really not much in the way compared to B, so I think we're probably good by labeling this one point A and using the unknown point, or the point we're interested in, as point B. So let's start off with our energy equation, and hopefully we can agree PA is gone, open to atmosphere. VA is gone because we're in a large reservoir. ZA is going to be 12 meters. HA and HR are gone. HA, there's no devices adding energy. HR, no devices removing energy. And HL is going to be the friction that we're going to have to calculate. PB is what we're interested in. V, which actually here is going to be VB, or V anywhere in the pipe for that matter. And ZB I'm going to cross out because we are on the datum. Okay, so let's see. We need HL. Need HL. ZA we're good. PB we're looking for. VB we've got. So let's get, first step, Reynolds number is equal to rho VD over mu, which is equal to VD over nu. Either one of those we can use. It really doesn't matter. We've got all of them, so why don't we just do this one? So we'll go ahead and we'll say 1.99 meters per second. Our diameter was 0.098 meters. Nu, our kinematic viscosity, 1.30 times 10 to the minus 6 meters squared per second. And that gives a Reynolds number of 1.5 1.5 times 10 to the 5. Now I've got 1.50, but I think we know now with our Moody diagram whether, we use 1.15, 1.51 or 1.52 or 1.49. We're not going to be able to tell the difference on our Moody diagram, so 1.5 is good. So now we need to get our d over epsilon as well. Actually, one point I forgot to make, this is clearly turbulent since it is greater than 4,000. You're going to find that most of these do turn out to be turbulent, although we will sneak in a couple of examples of our laminar as well. Diameter 0.098 meters, epsilon 1.5 times 10 to the minus 6 meters, and that gives us a value of 65,333. So we need to go to our Moody diagram, get our Reynolds number and d over epsilon, and let's see, we've got a Reynolds number of 1.5 times 10 to the 5. Here's 10 to the 5 right here. 2 times 10 to the 5, that's 1 times 10 to the 5 right there. And we want to go up to 65,000. Now, note here, 20,000 is coming up, up. And as we get close, we're going to see that, well, really it fades away, doesn't it? 65,000 is a lot bigger than 20,000 as well, so we're effectively right on the smooth pipe line, maybe just a hair above it. So that's where I'm going to plot. So don't be frightened by that, the fact there's no 65,000. It just means that we're really converging hard onto that smooth pipeline. So I am going to read across, that's our old one, and I read across, and I am about here, so I'm going to say that I got in here, that's 0.016, so that's 0.0165, if you can read that one. And it's about where we are, maybe a little bit lower, but that'll do for what we're doing. F is equal to 0.0165 from the Moody diagram. So HL is FL over dV squared over 2G. And so we have, let's see, 0.0165 times our length, and I'm just going to go through this quickly. We've got 70 meters plus 12 meters minus 1.5 meters. That might not make a lot of sense for the moment. Let me write it down and come back. D is, let's see, we've got 0.098. Velocity was 1.99 squared over 2g, and that comes out to be 2.7 meters. Okay, now just to go back to this L really quickly, we've got 70 all the way across, so this amount here all the way across, that much is 70. Hopefully we can agree on that. We've got, let's see, 12 minus 1.5, right? So this total distance here is 12, but we don't have any of that. That's 1.5. So we've got 7.5 here, and we've got the remainder here. So all of that, this plus this, so we've got 12 minus the 1.5 will give us the amount here and here. Hopefully that works for you. Sorry, I'm trying to be quick here. So finally then, we can go back to our equation. And we've got ZA is going to be 12 meters minus 2.7 meters is equal to PB over 9810 plus 1.99 squared over 2G, and PB should come out to be 88 times 10 to the 3 pascals. Okay, so hopefully that works out for you, and talk to you soon.